you about what we're doing today. So going back to what we've already done. We've done elimination on a system of equations with two variables. So let's say you had something like this. Which of those variables is easiest to solve for by elimination right now? The y, right? Because if you added those two things, what would happen to the y? They would cancel. Then you would have one variable left, and it would be very easy to solve that. Okay. The problem today that we're going to have to do is, what about when you have a third variable in your system? And eliminating one variable still leaves you with two left. So you can't immediately solve. Okay? That's our goal for the day. But when I first set this unit up for you, I talked about how if you have one variable, you only need one equation to solve for that one variable. If you have two variables, you need two equations. And that's what we did Monday and Tuesday. We solved those systems. How many equations do you think I need if I just solve for three variables? Three equations. And so today we're solving stuff that looks like this on the iPhone board. Variables. Now there's more than one way of doing these. The way I'm going to, and you might prefer a different way, especially if you took pre-AP Algebra 2 here last year, because Ms. Arnold was telling me how they do it differently than what I'm about to show you. If you prefer that way and you can remember it, that's okay. But the reason why I'm sticking with the way I'm doing it today is it sets a good foundation for how we will solve matrices in the next unit. So the way I'm doing it will be the same way as we do matrices. And so that's why I'm doing what I'm doing today. But you're welcome to choose your method. So as long as you get the right answer, I'm okay. So here's how we begin. We're actually going to do the problems in different order. Like that first problem on the right, I can usually go left to right and then left to right. That first one to the right is easy, and so we're actually not going to do it first because it can be a little bit misleading as far as the process goes. So we're going to skip to the one on the bottom left because it's the only one that uses every single step in the process, and I want you to see it. So we're going to start with this one right here. There are three equations, and there's three variables. I want you to please read step 1 on your notes and see if this system already satisfies step 1 or if we have some work to do. Yes, right? Step 1 is done. We don't actually have any other work to do. So, step 1, done. Step 2. So read step 2 with your eyeballs and your brains. It says select a variable to eliminate. There are three variables here. It does not matter which one you choose to eliminate. As long as your math is good, you will have the right answer and the same answer as anybody else, even if they chose a different variable. The variable I'm going to choose for this one is y. I'm just going to make a note about that. That we're going to eliminate y. And the second part of that step says this. Use two different combinations of any two equations to eliminate that variable. I like to make little symbols next to each pair of equations that I choose to help me keep it straight. So here are the symbols I'm going with today. I'm going to choose the first two because they would already cancel out by right now, like without any additional math. So I'm going to choose the first two, and I'm going to put stars by. And then I'm also going to choose the second two because they have opposite signs already for the y, and I can work with that easily. So I'm going to put hearts by those. That'll be my heart system. And I'm going to use red for the heart because hearts are red. Unless they're in your body and you haven't been cut open and they haven't been hit with oxygen yet. I'm going to talk about that. So let's do the star system first. I can add them right now to eliminate the y's. But before I write it down, I'm going to do something. And you'll see this in my keys, in my homework, and in the notes. I'm going to call these R1, R2, and R3. What do you think that R stands for? Rows, right? So that's row 1, row 2, and row 3. I am going to add the two of them. This just helps keep stuff straight because this problem requires a lot of writing and stuff, especially if you feel like you jump all over the page when you're solving a problem. At least putting this notation down can help you remember what you did. Also, almost as importantly, if I'm coming to try and find where your mistake is, this helps me know what you did. It's not required for you to do it, but it does help me figure it out. So I'm going to add row 1 and row 2. So I got, here's my row 1. And then row 2. We're going to add them and not equal. X plus z equals 2. Now I can't solve right now because there's still two variables, but we're going to use this in a little bit. Right now I'm just going to hang out. Okay. So I chose those first two equations. That's my star system. I eliminated the y. Now I'm going to use the heart equations. I'm going to eliminate the exact same variable. You don't have to like move to a different variable this time. You still want to eliminate y. So here's my work for the heart equation. To just mark them so I can remember which combinations I chose. Okay. Like, and it didn't even have to be like I'm about to do the math on row 2 and 3. I could have done 1 and 3, as long as it was different from the first two that I did. So looking at those two heart equations, I'm trying to cancel y, so I really want what number in front of this one? 2. I'm going to multiply that by 2. But you can't just multiply that one thing by 2. It has to be everything by 2. So I'm going to do 2 times row 2 and add it to row 3. One thing I want to give you a reminder about, when you're multiplying a row by a number, be sure you multiply both sides of the equation by that number. So I need to multiply that 3 by the 2 as well. So 2 times row 2, I'm just going to do that in my head, is 8x minus 2y plus 6z equals 6. 8x minus 2y. And then 3x plus 2y minus z equals 4. And now we add them. So the y's are gone, and I'm left with 11x plus 5z equals 10. So that is set to eliminate one of the variables. I eliminated y. I chose 2 different combinations of 2 equations, solved those, or used elimination on those 2 systems, or those 2 combinations, and I have this. Now read step 3 to yourself. It says to solve this new system with the 2 variables, you can use either substitution or elimination. I'm going with elimination. I prefer elimination. It's also what we'll do when we do matrices. So I'm going to stick with that. Think like a teacher. Which variable do I feel is easiest to eliminate with elimination? The z, right? So this one, that's because this z is just a word. So what do I need to multiply that first row by? -5. So that gives me -25x minus 5z equals -10. I'm going to add that other equation to it. The z's cancel, which is great. What else cancels? The 10. That's a coincidence. Okay, your constant won't always cancel. So don't feel like that was something you should see happen every single time. And now I solve for x. I have one more step. Divide by -14. And here people will pause because they see a division. They see a 0 and they're like, there's something weird that I'm feeling about division with 0. That weird thing is this. You can't divide with 0 on the bottom because that's undefined. But it's okay for 0 to be on the top. 0 divided by anything is what? 0. So x equals 0. I feel like I did enough math. I want to just walk away from this problem. Am I done? I still need to find what? Y and z. I have x. I have x equals 0. So read step. We're actually, okay, let me back up a little bit. We're actually not done with step 3. Step 3 says to solve the system you created. I found the x for that system. Which other variable was in that system? The z, right? So I'm going to go to either the red equation or the blue one. Which one do you want? Blue. And plug that x equals 0 in to get the z. Right? I'm taking this, plugging it in here. I'm doing that right here. So 5 times 0 plus z equals 2. What is 5 times 0? 0. Nothing, right? All day. So 0 equals 2. Now am I done? No. Of course not. Of course not. So we have x and we have z. We still need y. So read step 4 to yourself. How come it requires a lot of work that's not. So step 4, substitute the values you found back into one of the original equations and solve for the third variable. Which one do you want? 1, 2, or 3? Which one? 1. All right. So here we go. That's x plus y minus 2z equals -1. We already know x. We already know z. So x is 0. Y stays y. Why? Because we don't. And then minus 2 times z, which is 2, equals -1. So that's really easy. You just do some math. That's -4, and then you add it to both sides. Y equals 3. And then read step 5 to yourself. It says write your solution as an ordered triple. It just means a point. We're so used to saying ordered pair that the two words just kind of go together and make one term. But the word pair means how many things? 2. So now that there's 3 variables, we call it an ordered triple. And I want to caution you about something. Don't just write the numbers in the order that you found them. Pay attention, they go in alphabetical order, x, y, z. So x is 0, y is 3, and z is 2. We didn't find them in that order, but that's how they need to be written. So that is, in all its glorious detail, this entire system. Okay. The next problem that I want us to work, still not the easy one, I want to work the bottom right one next. So I'm going to guide you through the first few steps and then give you some time to work it on your own before we talk about it. So step one, make sure all of your equations are in standard form. Take a minute and look, because if your y and z is mixed up on one, you're going to mess up all your stuff. How do you feel about that? Just done? Done. Okay. So step two, select a variable to eliminate. Look at it for a moment and decide which one you want to get rid of. Doesn't matter. You can choose any of them. Raise your hand if you figured out which one you're going to get rid of. Who has figured out? Okay, I should thank you all. Thank you all. Right. Now that you know which equation you want to eliminate, do the star and heart thing, or choose whichever symbols you like. Just mark the two pairs of equations you're going to use to eliminate your variable. And then take a few moments and do that. Here's the interesting thing about this problem. If you chose to eliminate x or y, what did you find happened on that second round of elimination? I think, that's right, two variables canceled out, right? Instead of just one, which makes your math easier. It actually makes your problem go faster. However, if you chose to eliminate z, I don't think that happens for you. Did anybody successfully do z for their whole problem or to get started? So for z, you have to follow every step. We're going to do x or y. Which would you like? X. All right. I heard x first. So as step one done. Step two, we're going to eliminate x. Looking at those, I'm going to just quickly decide that, well, I'm going to do the same order as the last one. I'm going to do the first two together, and then the second two together. So here's my star system. If I were to add right now, the x's don't cancel. But they would cancel if I multiply the second row by -3. So here's what I'm going to do. Row 1, -3 times row 2. -3x plus 6y minus 9 equals 9. Then we add. The x's cancel. I get 7y minus 11z equals -26. And that's for the stars. Here's the hearts. I'm going to give myself a lot of room. For the hearts, I want this x to have a -4, so it cancels out with that. So I'm going to do -4 row 2 plus row 3. Here's what that will look like. So I've got -4x plus 8y minus 12z equals -40. -40. And then add row 3 to it. What happens here is that the x and y's cancel. And I have -7z equals -35. That is okay for that to happen. It's like a little happy birthday present. That you didn't know you were going to get. So divide by -7 to both sides, and you get 5 for Z. And this is step 3. And we need to finish off that system before we move on to step 4. So I take that Z equals 5 and I plug it into that equation that I got with the first round of elimination. And that is 7y minus 11 times 5. We know that that is Z. So that's negative 55. I'm going to add it to both sides. So 7y equals 28. That means y equals 4. And oh my gosh, we're still in there. So that's the end of step 3. So here's step 4. Take both of those things and plug them into any of the original equations. Which would you like? Equation 1, 2, or 3? 1. Okay. So that is 3 times x, which we don't know yet, so it stays x, plus y, which we know is 4, minus 2 times z, which we know is 5, equals 3. So this math right here, 4 minus 10 is negative 6. I'm going to add that to both sides. So 3x equals 9, x equals 9. And the last step is to write it as an ordered triple. Is it 5, 4, 3 or 3, 4, 5? 3, 4, 5, right? Why would I give you that option 5, 4, 3 to see if you go? No, because that's the order we solved them in. So sometimes students will just write that in the order that they found the answers. And as a little bit of trivia today, this set of numbers, 3, 4, 5, is called a Pythagorean triple because if you put it into the Pythagorean theorem, it would work. 9 plus 16 equals 25. So, you try now that first problem that we skipped. It's shorter than these because if you look at it, what's going on? There's no z. How many equations is missing the z? 2. So it's basically the same process, but you're already starting at step 3. Does anybody need the screen up anymore? Right. So because neither one of these has a z, you can pretty much just start at step 3. Take a few minutes. I'm just going to work the problem up here. Some of you are done. Some of you are still working. So if you're done, you can see how to compare your answer. If you're still working, take your time. We have plenty of time left in class, but the work will be up here whenever you're ready to see it. Don't look at it till you're ready. You can't unsee what you have seen, and then you feel like you understand what you're doing when you're not. Let me pass out your homework.